In this section, you're going to see several properties that you're going to be using related to logarithms. And in this section, you're really going to just be using the properties to rewrite logarithms, but you'll see that these properties are helpful in the next section when you're trying to solve logarithmic equations. So this is just kind of building up to helping you solve more complicated logarithmic equations. So first, the product rule. It says that if you're taking the log of a product, you can actually break it up into a sum of logarithms. So you see it's still log base b all the way across, but instead of being m times n, it's log base b of m plus a separate log base b of n. Similarly, you have the quotient rule. If you have a quotient, that splits apart into a subtraction or a difference. And so whatever is in the denominator has a negative in front of the log. That's how you know what is in the numerator versus what is in the denominator. So if you see the log base b of m, it has no sign in front, that's positive, that means it's in the numerator. This negative in front of the log base b of n means that the n is in the denominator. And then we have the power rule. So the power rule shows you that you can take a power and you can actually move it out front of the log as a product. So the n comes down as a multiplication. So let's look at how to use some of these rules. So expand each logarithm as much as possible. Rewrite each expression as a sum, difference, or product. So right now you can see in number 1, we have the natural log of all these products, right? 3 times a times b times 5 times c. So each of these can be broken apart into a separate log using addition. So we'd have the natural log of 3 plus the natural log of a plus the natural log of b plus the natural log of 5 plus the natural log of c. And so here I think the common mistake is to just think that 3ab is one thing, and then it has a little times 5c. So that makes you think that you could just do this, which you can do this, but that's not all the way expanded. It's not expanded as much as possible, and it tells you in the directions to expand as much as possible. So don't stop there. You want to completely break it up like I did here. All right, number 2, you can see that this is the quotient, right? We have a division. And so first we're going to have log base b, base b of 5 because it's in the numerator. And then the denominator has 6x. But remember, 6 and x are separate things, right? It's 6 times x. So you're going to do minus log, I keep putting the wrong thing, log base b of 6 minus log base b of x. And so each factor in the denominator has a negative in front of its log. So you can tell that the 5 is in the numerator because that log is positive. The 6 is in the denominator because that log is negative, and the x is in the denominator because that log is negative. All right, number 3. Again, we have quotient. So we're going to do the natural log of a squared, actually a to the negative 2, right? And then in the denominator, that means I'm going to have a minus natural log of b to the negative 4, and c is also in the denominator, so that will be a minus natural log of c to the 5th. And now what you want to do is use the power rule. So if you have an exponent, I have an exponent in each of these, I can move the exponent down in the front of the log. So this would be negative 2 natural log a, and then minus a negative 4. So it's going to be plus 4 natural log b, and then bring the 5 down, so it'll be minus 5 natural log c. And that's as much as you can do. Now, here it changed things. So I just want to point this out. So this is the answer. But remember I said that the sign in front of the log tells you where it should go? And so this negative in front of the 2 natural log and the 5 natural log could put those in the denominator. So you could interpret this, if you're going the other way, as having the a in the denominator, because that negative in front was with the log, and then the c in the denominator with a 5, and a b in the numerator with a 4. But if you remember, if you look at our original thing, if you remember that negative exponents move to the opposite side of the fraction, you will see that these are actually the same thing. And I should have put natural log in front, of course, and I didn't, but I should have. You'll see that these are equivalent. So just a different way to write it, okay? So what's boxed in red is the answer, but don't be confused with the signs changing when you bring the power down. Okay, next, condense to a single logarithm if possible. So we're going the opposite direction of 1 through 3. So now they have it all broken up into sums and differences, and we have to put it together in one log. The important thing to note is that you have to have the same base. So they all have to be base, like in number 4, base 3. If they're not all base 3, you can't put them together. So we have log base 3. They're all pluses, right? And actually there should have been a plus here. Okay, I'm missing a plus. So it should be log base 3 of 11 plus log base 3 of b. So if it's all pluses, that means you're just going to be multiplying them all together. So 2a times 11 times b. And so that would be log base 3 of 22ab. And that would be it. That's as condensed as you can get it. Okay. All right, so number 5, here you see we have some positives and some negatives. So whatever has a positive in front of the natural log, that's going to be in the numerator. So a is positive, so it will be in the numerator. And then the d and the c, there's a negative in front of that natural log. So that indicates that those variables are going to be in the denominator. And that's all we can do. That's it. All right, and then number 6, we have logs with no base written, so it's understood to be log base 10. So log, it's a plus. There's no negatives here, so this is just multiplying these together. So that would be the log of 6x to the 9th. And that would be it. Okay, so make sure you know how to condense and expand. You should be able to go either way with those rules. Okay, and then the last thing we're going to look at in this section is the change of base formula. So when you want to change the base, you have this formula here. The reason you have this is because traditionally you might have to use charts to find answers, or the older calculators couldn't handle anything other than traditional base 10. So if you had something like log base 3 of 5, you wouldn't be able to just type that in your calculator. Now, even the really cheap calculators, a lot of times will have a button that looks like this, and so you can put whatever base you want in there. So if you needed to change the base so that it would be a traditional, like let's say base 10, you would change it to look like this. So it would become log of 5 over log of 3. And so the numbers come from here. Whatever you're taking the log of stays like that on top. Whatever the base was, you're going to be taking the log of that on the bottom. And it becomes this quotient. And so usually you just change it to the traditional base. So if you have a log, it will be base 10. If you're changing to the natural log, it would usually be base e. Now, really you can change it to any base you want. So you could make them both be, let's say, I could do it like that, or I could do log base 8 of 5 over log base 8 of 3. So you can change the base to be whatever you want. Just usually you use the traditional understood base. So let's try a couple of these. Number 7, rewrite each expression as an equivalent ratio of logs using the indicated base. So we want to have log base 7 of 15, and we want to use base e. So this would be, since we're going to change it to base e, you can see we have an example right here. So you can change it to base e using the natural log. So this would be the natural log of 15 over the natural log of 7. And you don't have to write the e because it's understood to be an e when you're using the natural log. And so that would be what they want you to write. Okay, and then it says number 8, log base 14 of 55.875 to base 10. So if they want base 10, that means they want the traditional log, the log. So we'll do the log of 55.875. So the numerator is always going to look similar to what you had originally, just with the different base. And then the denominator is always the log of the base. So log of 14 in this case. And that would be it.